Okay, now today we will also learn the derivative of the higher order of implicit functions. So what if we're given an implicit form and then we're asked to find the second order, the third, the fourth, or the fifth order of this implicit function? We have here an example. Find d squared y over dx squared of the implicit function. We have an equation of a circle, x squared plus y squared is equals to 25. Now we have learned from implicit functions that we're going to follow the steps in finding the derivative of implicit forms. So all we need to do is apply derivative to all our equation. No longer have to transpose and change our equation. So applying derivative with respect to x of x squared plus y squared is equals to 25. So basically, we're going to apply all the rules that we have learned from derivative. So this is sum and difference rule. Apply derivative independently to all our terms. The derivative of x squared, we now have 2x. The derivative of y squared, since this one is not agreeing with this variable, so we're going to apply chain rule to this one. So we now have 2y, and then the derivative of y with respect to x, which is dx over dx, equals, since we have an equal sign right here, derivative of 25, which is a constant number, that is 0. So we have learned from implicit that we're going to isolate dy over dx terms that has dy over dx in this side of the equation, transpose this one to the other side. So we now have negative 2x. So to find dy over dx alone, we need to get rid of 2y, so that is why we're going to divide both sides with 2y. Canceling 2y, and then we now come up with dy over dx, which is equivalent to, we canceled out 2, so that is why we now have negative x over y. This is the first derivative only. We're asked to find the second derivative. So we'll take this one into the new level, or finding the derivative of this term. So finding the derivative of this term, we are simply applying quotient rule. There are two functions divided together. The negative one right here, we could write it in front our derived form. So that is a constant multiple. Obviously, this is imaginary negative 1. So we're going to write negative 1 ahead, and then we're going to find the derivative of this one. Okay? So applying derivative again to our implicit form. So that is dy over dx is equals to negative x over y. So applying again another derivative to our first derivative, so we will double the d. We now have d squared. Y, double the dx, we now have dx squared. So obviously this is quotient rule. So when we say quotient rule, we're going to apply the quotient rule that we have learned. Square the denominator. Copy the denominator, the derivative of x with respect to x, that is just 1. Minus, copy the numerator. Copy the derivative of y with respect to x. So this is the blue right here, dy over dx. We have wrote our negative right here, negative 1, imaginary. We have separated this one so that we will not be having trouble in utilizing the symbols or the signs. Is it positive or negative? Let's just write it in front. Okay, now next. So we can arrange or simplify this one. Okay, so d squared y over dx squared is equivalent to negative, and we have our quantity or our term y minus x dy over dx over y squared. If you think that this is the final answer, since this is already equivalent to d squared y over dx squared, it's not yet the answer. Why? Because it contains dy over dx right here. We need to substitute value of dy over dx. What is the value of dy over dx? We have solved a while ago that dy over dx is equivalent to negative x over y. So we're going to substitute the value of dy over dx from our previous solution. So we have the dy over dx is equivalent to negative x over y. So we're going to do a little bit of algebra to this one. So we have this term is multiplied to this term right here. Negative and negative, this will become positive. Numerator times numerator, this will become x squared divided by y. So we still copy our denominator, y squared. We now have d squared y over dx squared is equivalent to, we still have our negative, y plus x squared over y squared. So we're going to manipulate the simple algebra right here. So that is recalling a minus b over c. We have an imaginary 1 right here. So cross multiplying, we have ac minus b divided with our denominator c. So here, y times y, we now have y squared plus x squared over y. This is the numerator term. We still have our denominator, y squared. Okay, so this is now our equivalent. dy squared over y over dx squared is equivalent to this term right here. Recall, we can manipulate this one again through simple algebra. Recalling a over b divided with c, or we could have imaginary 1 right here. Dividing fractions, we take the reciprocal. So that is why we now have a over bc. Retain a, multiply b and c. Retain a, multiply b and c. So in this term, retain y squared plus x squared multiply y times y squared. We now come up with this result. d squared y over dx squared is equivalent to, we still have our negative, y squared plus x squared over y times y squared, which is y cubed. Arranging the numerator, I wrote x before y. So we now have x squared plus y squared over y cubed. Again, this is not yet our final answer. If you consider this one as your final answer, this is not yet the final answer. So we need to substitute value of this term right here, x squared plus y squared. Familiar, this is the original equation. X squared plus y squared is equals to 25. Meaning to say, we're going to substitute the value of x squared plus y squared, which is 25. So this is our final answer. As you can see, we have to convert our x squared plus y squared to its equivalent value, which is 25 from our original equation. Now this is our final answer. Take a look on our example. Take a screenshot if you'd like. And let's proceed with another example. Find d squared y over dx squared of the implicit function. We have our implicit function, x raised to the power of 1/2 plus y raised to the power of 1/2 is equals to 16. Yes, we have learned from implicit function that we no longer have to transpose, rearrange, or even alter the equation. All we need to do is to apply derivative with respect to x. And we have a function that has a variable that agrees with respect to x and a variable that does not agree with respect to x. So we need to, again, apply the basic rules that we have discussed. So applying derivative of x raised to the power of 1/2, power rule, 1/2 x raised to the power of negative 1/2, since we're going to subtract 1 to the exponent, plus, since this is agreeing, that is just equivalent to 1, plus 1/2 y raised to the power of negative 1/2. The derivative of y, since this one is not agreeing, so we need to apply chain rule. Derivative of y with respect to x, that is dy over dx. And then we have the derivative of 16, which is 0 right here, obviously. Now we're going to isolate this term on the left side of the equation and transpose this one to the right side. So we now have come up with 1 half y raised to the power of negative 1 half dy over dx is equals to negative 1 half x raised to the power of 1 half. Now, what shall we do next? Get rid of 1 half y raised to the power of negative 1 half so that we can find dy over dx. Okay, dividing both sides with 1 half y raised to the power of negative 1 half, cancelling this one. We now come up with dy over dx as negative x raised to the power of negative 1 half over y raised to the power of negative 1 half. This is not yet our final answer. Since we have negative exponent, we're going to take the reciprocals. Y will be written in the numerator, x will be written in the denominator so that we could have positive exponents. Again, do not forget the reciprocals. We have learned that one from algebra. Now, this is our first result. This is the dy over dx. We're asked to find the second derivative. So we're going to, again, apply derivative to our first order. So, applying the operation of derivative d over dx to this side of the equation, this will become d squared y over dx squared. Applying derivative to this one, that is again another quotient rule. So we have a negative 1 imaginary. Let's write it in front so that it will not bother us any longer. Let's apply quotient rule. Square the denominator. So we have square the denominator. We will be cancelling the square root. Copy the denominator. Derivative of y raised to the power of 1 half. We have 1 half y raised to the power of negative 1 half. And then the derivative of y, since it is not agreeing, dy over dx. Minus, copy the numerator, y raised to the power of 1 half, and then the derivative of the denominator, 1 half x raised to the power of negative 1 half. Now, let's do simple algebra. Notice we have 1 half in this term and also 1 half at this term. So these are constant value. Let's write it in front, followed by x, followed by y, followed by dy over dx. Okay, started with x, followed by y, and then we have this one. Okay, d squared y over dx squared, we have written 1 half and 1 half in front, followed by x, followed by y, dy over dx, followed by x, followed by y, and so on. Okay, notice the two term has both 1 half. Let's factor that one out. And we still have to substitute the value of dy over dx, which is our result right here. Dy over dx is y squared over x squared. So now, let's substitute this one and factor out 1 half. We now have our 1 half. We have our dy over dx right here. This is the previous dy over dx. Notice we could cancel x raised to the power of 1 half with the 1 half right here since this is multiplication. What's left is y raised to the power of negative 1 half multiplied with y raised to the power of 1 half. That is just 0 or equivalent to 1 since we can cancel that one out. Negative 1 half times 1 half plus 1 half, that is 0. The exponent is 0. Anything raised to 0 is 1. And what we're left with this side of the equation is that we have, since this is negative, write it down. Its exponent is negative, so we could find its reciprocal. So we could write it below y raised to the power of 1 half. Okay, so this is our y raised to the power of 1 half. This is positive, and this one is negative. So I have written this below y raised to the power of 1 half. So we're left with, after the cancellations, with this one, negative 1. Since this is y raised to 0 or 1, and since this is negative, so this is negative 1, minus, we have the fraction y raised to the power 1 half over x raised to the power of 1 half. Again, let's recall a simple algebra. A minus b over c. So we have our a. So we now have ac minus b. So multiply x raised to the power 1 half times negative 1, negative x raised to the power 1 half minus the operation, copy y raised to the power 1 half divided with the denominator, x raised to the power of 1 half. So this term right here divided by this term right here. We still have our negative 1 half outside, and we still have our x on the denominator. Again, we can manipulate this one through simple algebra. A over b divided with c, so that is equivalent to a times bc. Okay, so manipulating this one, we'll just have to multiply b times c. Okay, so we now have here negative 1 half, negative x squared raised to the power 1 half minus y raised to the power 1 half. And then we have x raised to 1 half times x. 1 half plus 1, that is 3 halves. Right here. Notice we have a negative number here, negative 1 half. If we're going to distribute negative to our numerator, we now have positive. We now have positive x raised to the power 1 half plus y raised to the power 1 half over x raised to the power of 3 halves. Now next, this is not yet our final answer since we have this term involving x and y both raised to 1 half. Notice that is our original equation. X raised to the power 1 half plus y raised to the power 1 half, that is equivalent to 16. Therefore, this one is equivalent to 16. So 16 divided with 2, that is now equivalent to 8. So our d squared y over dx squared, or the second order of our implicit form, is equivalent to 8 over x raised to the power of 3 halves. Let's zoom out so that you can see the process of our implicit differentiation. Okay, so thank you so much for listening.